Today we will be moving on to the permanent magnetism of the ship, which is generated in hard iron, and then we will move on to the coefficients. So that's the plan for today. So ready, beta? Shall we go ahead with the presentation?
Yes, sir.
Sir, just
Okay.
few things.
बोलो बेटा, बोलो बेटा.
सर जैसे जो आपने नोट्स कल भेजे सर, एंड दैट टिल वेयर वी हैव लर्नड यस्टरडे, तो एक लाइन है सर, द वर्टिकल कंपोनेंट इज कॉल्ड z, इट एक्ट्स डाउनवर्ड इन नॉर्दर्न हेमिस्फीयर एंड अपवर्ड इन southern hemisphere. However, the card is so constructed as to restrict dipping by keeping its center of gravity low. मतलब कार्ड की भी सेंटर, ओके सर, कार्ड की सेंटर ऑफ ग्रेविटी.
Okay, I'll tell you beta उसका मतलब क्या है. This is basically the construction of the compass card. What happens is, you see, the compass card is having a magnet. So if you are not at the equator, you are at the North Pole or South Pole, there will be a tendency of the card to tilt up or down in one of the way. Right?
Excuse me, sir. Sir, I cannot see the video.
Beta, can you see my face?
No, sir.
Yes, sir, I can see.
Okay, so Prabhat, I believe, cannot see. So beta, just log out and log in again.
Okay, sir.
Okay, so there is a tendency that the card tilts up or down. So what is done is, the card is so constructed that its COG is at the bottom, COG is down below. So when the COG of the card is down, whatever tilting is generated because of gravity, the card resists any tilting. So this is what is done, because we don't want our compass card to tilt up and down. We want it to remain horizontal. So this is a construction feature of the card.
Copied, sir. And so one more thing, sir. This in permanent magnetism, in hard iron structure like hull, decks, bulkhead, tank top, and induced magnetism, soft iron structure like beams, girder, mast and funnel. शिप तो पूरा सा मेटल का ही है, तो हमें कैसे पता चले कौन सा इसमें सॉफ्ट है, कौन सा इसमें हार्ड है?
Okay, मैं अभी permanent magnetism कराऊंगा hard iron, so that will become clear to you.
Copy, sir. And permanent magnetism में सर एक जगह था, is acquired by hard iron in the ship when it is built, heading in a constant direction in the yard, continuous heating hammering causes HL molecules to align themselves. HL molecules इसको कहते हैं सर?
Hard iron molecules, बेटा.
Okay sir, hard iron. Copy, sir.
You're right. ये अभी हम करेंगे. I'll tell you about the hard iron and permanent magnetism.
Yes, sir.
Okay, great beta. So let's move on to the presentation. So this was the last thing what we did yesterday, the soft iron, HSI and VSI. Now moving on to the permanent magnetism in hard iron. Now moving further to ship's permanent magnetism. Till now we have gone in detail and understood the induced magnetism of the ship, which is acquired by the soft iron structures. We have seen their relationship with the heading of the ship, with the position of the ship, whether the ship is on the equator or at the pole, southern hemisphere, north hemisphere, horizontal soft iron and vertical soft iron in detail. Now we move on to the ship's permanent magnetism. The permanent magnetism in the hard iron structures of the ship is acquired during shipbuilding, during the building of the vessel in the shipyard. Now to give you an idea about this, you see in this diagram, this ship is made fast to the berth or at a yard or a dock. and it is situated in this particular orientation. The ship is being built in this particular orientation, and the pink color arrows which you are seeing, they basically represent the magnetic field of the Earth. The vessel is in northern hemisphere, that's why you see all these lines are going into the surface of the Earth, and the angle at which they are cutting the surface of Earth is the dip angle at that particular place. So the ship is exposed to this particular magnetism of the Earth's magnetic field. The hull of the ship will lie in this position till the time the construction of the ship is complete. In a yard or in a dock, when you start the shipbuilding, laying down the keel of the ship remains in the same orientation till the time it is ready to be launched for sea trials. So the Earth's magnetic field will keep on affecting the ship in this particular orientation only. So you can see the magnetic field lines are entering from the top deck of the ship, and they are leaving out from the keel of the ship. So the hull of the ship lies in one constant direction and is worked upon. When the ship is being constructed, we will be welding the plates, we will be hammering them, bending them, heating them. A high voltage electric current will be passing at the time of welding. So we will be using grinders, cutters, all these instruments on them. So all the ship's plates which are being fitted will be worked upon at the time of shipbuilding. Now, during this entire process, which happens over a long period of time, it may take 1 year or it may take 6 months for the ship to be built. So during this long period, the Earth's magnetic field continuously acts on the hull in the same direction or the same orientation. Now, since we are working upon all these metal plates which are being fitted on the ship, and the Earth's magnetic field is acting on it in the same orientation, it generates permanent magnetism in these hard iron structures. So I told you that hard iron structures are those structures which are extensively worked upon at the time of construction of the ship or shipbuilding. Like, say, for example, a keel plate, a deck plate, a bulkhead. Now, when you are fitting this, let us assume there is a deck plate. You are fitting this deck plate on the deck of the ship during its construction. Now, you will be cutting the plate, making it to size. You will be bending it as required. You will be hammering it. Then you will be welding from the seams. Then you will be welding a stiffener or a longitudinal on it or a transverse beam on it. So all these things, when they are happening and we are working upon this particular deck plate, the Earth's magnetic field is acting on that deck plate in one particular orientation. And this Earth's magnetic field acting on it during all this jobs or work being done generates a permanent magnetism in these structures. Since a lot of working upon is being done, they are hard iron structures, and the Earth's magnetic field generates a permanent magnetism in these hard iron structure. Now, as this is permanent magnetism, once the material acquires it, it will not then change with time or with the position of the ship. The permanent magnetism, once acquired, remains there in the structure, and it will not change with time or when the ship changes its position.
Sir, I have one small doubt, sir.
Go ahead, Beta.
Sir, in the hard iron, soft iron differences, is there nothing to do with the material? Is it only to do with whether it is worked upon or?
That's correct, Beta. That's correct. The material remains the same. You see whether it is a stiffener or it's a 4.5 longitudinal or a mast or a deck plate, keel plate, all of them are made up of mild steel. So material is the same. The only difference is some of them are worked upon and some of them are not worked upon. They are just cut to size and fitted on board. So that is the only difference.
Okay, sir. Thank you.
Okay. Any more doubts up to here, beta?
Yes sir, one doubt please sir.
बोलो बेटा.
सर मेरा डाउट ये था कि जब ये शिप बिल्डिंग होता है तो ये तो भी फिक्स्ड एरिया में है जहाँ पे जो लोकेशन शिप बिल्डिंग हो रहा है, बट द अदर पार्ट्स लाइक द बिल्डिंग ऑफ दैट हल एरिया and making some bracket floors or making DV tank floors, that is done in some other places like far away. There is a difference of the location और जो magnetic field का जो एक्शन रहता है वो तो वहाँ पे अलग रहेगा ना, और जब हम लोग उसको ला के परमानेंटली बॉडी के शिप पे बिल्डिंग करेंगे वो एरिया का भी उस पर इफेक्ट पड़ेगा क्या?
Right, beta. That's right.
Okay, sir.
Basically, what happens is, beta, you can mute your mic now.
Yes.
Basically, what happens is some of the materials or some of the parts of the ship may be prefabricated. Like they could make the accommodation somewhere else, bring the full block, and then fit it on top of the hull. So that is also possible. Now the magnetism in that accommodation block will be bases where that was built. Okay, so there will be lot of pieces which will be there in the ship having different magnetic properties. Some plate may have its red pole towards the bow, some plate may have its red pole towards starboard beam, and so on. There could be many combinations. What we are interested is in the resultant of all those. To give you an example, अगर आप एक बॉक्स ले लेते हो, let us say you take a cardboard box और उसमें आप बहुत सारे magnets गिरा देते हो, lot of magnets you put in that. Now all those magnets are random direction. Somebody is pointing in this way, somebody this way. If you suspend that box with a thread, you will see it will always align in one particular direction. That is the resultant of all those poles. So there can be differences in the poles generated. They may be in different directions, but what we are ultimately interested in is in their resultant. Right, beta?
Okay, sir. Got it. Thanks.
Okay. Okay, moving ahead now. Now, since it is permanent magnetism, the poles which are generated, as we have seen, a blue pole is generated where the lines enter the material and a red pole is generated where they leave the material. The poles generated are also permanent. The course or the heading of the ship or the rolling pitching motion of the ship will not have any effect on them. Once these poles are generated, the rolling pitching of the ship, the course of the ship, the heading of the ship, the position of the ship will not have any effect on these poles because these are permanent poles. Now the ship which I showed you in the previous slide, the lines of force were entering on the deck and they were leaving out from the keel. So if there is a bulkhead, let us say you are welding a bulkhead in place, an intertank bulkhead, the topmost part of the bulkhead is going to acquire blue polarity and the bottommost part of the bulkhead is going to acquire red polarity, and these poles will remain permanent always, as they are permanent magnetism. The vessel is going to acquire magnetism both in the horizontal and vertical planes. I will explain this to you with the help of diagrams going further. A blue pole is acquired where the lines enter the material, and a red pole is acquired where the lines of force leave the material. Moving ahead now, beta. Now, as I told you that this permanent magnetism is acquired both in the horizontal. We'll go there, beta. Just complete this, then I'll show you.
Okay.
Horizontal direction and the vertical direction. Now let's try to understand that by making some diagrams. Let us assume that we have a ship being built at a yard which is on the equator. We have a yard somewhere on the equator and the ship is being built. Two ships are being built there. One of the ships is put in the yard heading in the southerly direction. So right now you see where my laser pointer is. This ship is being built in the yard on a southerly heading. This is how the orientation of the yard is. Now, if it is being built on a southerly heading, you see a red color pole here at the bottom or at the south. This is basically the south pole or the south magnetic pole of the Earth. And you see a blue pole at the top or north of the ship. This represents the north magnetic pole of the Earth, which has the blue polarity. And these dotted lines which you see, the dotted lines going from red pole to the blue pole, they represent the magnetic field lines of the Earth. We are aware that magnetic field lines come out of the red pole, which is the south magnetic pole of the Earth. They are all coming out from the red pole. And these lines of force, they re-enter or go into the blue pole or the north magnetic pole of the Earth. So that is why you see the arrows are always from red to blue. Now this magnetic field is affecting the ship which is being built. And all these magnetic field lines, they are entering into the ship structure from the bow side, giving it a blue polarity, and they are leaving out from the ship from the stern side, giving it a red polarity. Why the bow is blue in this case? Because wherever the magnetic field lines enter, that is the blue pole. And why is the stern red in this place? The stern is red because wherever the lines of force come out, that is the red pole of the magnet. So with the lines of force entering into the bow, it gets a blue polarity. And with the lines of force coming out of the stern, it gets a red polarity. Now, let's assume that there is another ship which is being built in the same yard, but in a different dock. And that dock has a northeasterly orientation. So you now concentrate on the ship on the right side. This ship is heading in a northeasterly direction. The south pole of the Earth is at the same location. North pole is at the same location. Magnetic lines of force of the Earth are moving in the same orientation from south to north. But with the ship heading in the northeasterly direction, now if you look carefully, the magnetic field lines are entering into the ship structure from the starboard quarter side. So you see, starboard quarter is where the lines of force are entering, and that is where a blue pole will be acquired. These lines of force are coming out of the ship structure from the port bow, and that is where a red pole will be acquired. So you compare both these ships now, you see with the change in heading of the ship, the horizontal positioning or location of the poles has also changed. So any doubts coming up to here, beta?
Sir, in previous slide, it was mentioned that it does not depend on the heading, I think, was for before this slide.
Okay, I'll show you the previous slide. Here it is, beta. You want to
okay, it means after it is acquired magnetism,
right, that is correct, beta. This is after the ship is built and it starts sailing. So once the poles are acquired, whatever course or heading the ship is on, it will not affect these poles since these are permanent.
Okay, got it. And sir, in this case, the next slide, the northeast easterly heading of the ship, the poles which are required permanently will have less, what do you say, this effect, like
They will
the
not
heading which
have,
is south.
you cannot say less effect. The effect will be there, but it will be in a different orientation. We will discuss how the poles in different directions affect the compass.
Like yesterday when we were reading that slide that it was mentioned, no, when it is like parallel to that side, it is most affected, the poles which are generated. But
Yeah,
then the
certainly,
orientation
certainly.
is little.
But the difference here will be, if the ship is heading south, you will see the induction will happen only in the fore and aft longitudinals. If the ship is heading northeast, you will have partial induction in the longitudinals, and you will also have partial induction in the outward ship beams also.
Okay.
So that is going to be the difference. Okay. चलें आगे बेटा?
Yes.
Yes, sir.
Okay, let's go. Now let's see the vertical positioning of the poles of the permanent magnetism of the ship. Now for this, let's make another diagram. In this diagram, you can see the Earth, and in the Earth we can see the north magnetic pole, which is blue, represented here, and you can see the south magnetic pole, which is red, represented here. And you see the dotted line also representing the magnetic field lines of the Earth. You can see from the red pole the lines are coming out and the lines are re-entering into the Earth's surface at the blue pole. Now let's assume a ship which is built in the northern hemisphere. You see these two ships on the top. This one is built on the northern hemisphere, at some place on the northern hemisphere. This ship also is built in the northern hemisphere. This ship is being built in the yard, somewhere located in the northerly latitudes. Now you see that when the ship is being built, the magnetic lines of force will be coming into the Earth's surface. So they will be entering from the deck of the ship and they will be coming out or leaving out the ship from the keel. So since they are entering into the deck of the ship, it will acquire a blue polarity. And since they are leaving out or coming out from the keel of the ship, it will acquire a red polarity. This is exactly the same situation for which I showed you the diagram in the previous slides also. We saw a ship standing in a yard and the magnetic field lines were going vertically downwards. So they were entering from the deck, giving it a blue polarity, and they are coming out from the keel, giving it a red polarity. So if the ship is built anywhere in the northern hemisphere, it will have a blue polarity deck and a red polarity keel of the ship. Now let's visualize a ship being built somewhere in the southern hemisphere. So this is the ship you see being built in the southern hemisphere. Now in the southern hemisphere, we are aware that the lines of force come out of the Earth's surface. So you see the lines of force coming out of the Earth's surface will enter from the keel of the ship, giving it a blue polarity, and they will come out from the deck of the ship, giving it a red polarity. So any ship which is built in the southern hemisphere will have a blue keel and a red deck. Any ship built in the northern hemisphere will have a red keel and a blue deck. So when you come to know the location where the ship is built and the heading on which the ship is built, you can find out easily what is the vertical and horizontal positioning of the poles. So the same thing is mentioned here. Vertical positioning of the poles depends upon the hemisphere where the vessel is built. Clear, beta? Go ahead with your doubts.
Sir, this positioning of the vessel in northern or southern hemisphere will decide the overall uh, positioning of the poles for the whole ship, or it is just for that particular deck, or means this red and blue poles. This will be for the complete ship, or just for some structure.
ओके बेटा, नाउ ये जो डायग्राम हम देख रहे हैं इसमें बेसिकली वी आर ट्राइंग टू अंडरस्टैंड कि शिप में जितने भी वर्टिकल स्ट्रक्चर्स हैं, दे कुड बी द मास्ट, द फनल और वर्टिकल स्टिफनर, एनी वर्टिकल स्ट्रक्चर, उन वर्टिकल स्ट्रक्चर के टॉप और बॉटम पे क्या क्या पोल्स जनरेट होंगे. सो दैट इज व्हाट डिसाइड्स what will be the top and bottom poles of the vertical structures. This is known as vertical positioning of the poles. And जो पिछली स्लाइड में हमने देखा था, which was changing with respect to the heading of the ship, that is the horizontal positioning of the poles. So all the horizontal structures like the fore and aft longitudinal, so they will have that particular polarity. Now इन दोनों को अगर हम combine कर दें, it becomes a 3D kind of phenomena. सो लाइक से फॉर एग्जांपल अगर आप नॉर्थ हेमिस्फीयर में राइट साइड वाला शिप देखो, तो इसमें अगर हम दोनों को कंबाइन कर दें, द ब्लू पोल इज गोइंग टू बी ऑन द डेक ऑफ द शिप क्लोज टू द स्टर्न, slightly closer to the stern, and the red pole is going to be at the keel of the ship slightly closer to the bow. So that is the overall permanent magnetism of the ship. Is that making it clear?
Yes, sir. Sir, then let's say there is a funnel, and it is also being worked upon, hammered, and everything is happening on it also. So over a period of time, it will also acquire permanent magnetism. The net magnetic effect of that funnel will be a resultant of whatever induced magnetism is there and the permanent magnetism, right?
That is correct, beta. Now, every structure will have some component of permanent magnetism and some component of induced magnetism. Because कोई भी structure जो है, अगर आप बोलते हो कि हमने उस पर वर्क अपॉन नहीं किया, let us say 4.5 longitudinal, one welding seam has to be put. So slight working is done there also. So there will be a slight amount of permanent magnetism in it, but the major portion will be induced magnetism. Now, when we classify the structures, we classify it basis its predominant form of magnetism. So longitudinal में अगर 80% induced magnetism है, हम उसे induced magnetism की कैटेगरी में डाल देते हैं. We call it a soft iron. Similarly, अगर funnel है या mast है, इनमें 80-70% अगर soft iron की properties हैं, we consider that structure as a soft iron structure.
Okay, sir. Thank you, sir.
Sir, this permanent magnetism is generally acquired during shipbuilding. Correct, sir?
That's correct, beta. It will only be acquired during shipbuilding. And later on, if the ship goes to a yard or dry dock and some steel renewal is done, that will also have its effect on it. So these are the times when permanent magnetism is acquired.
Okay.
Sir, this magnetism is affected only by steel structures or even electronic items also? Like if you see nowadays, many of the electronic items, they tell compass safe distance. So that also creates any magnetism?
Okay, but right now we are interested in the ship structure magnetism. So this is that permanent and induced magnetism. But you see everywhere you have a electronic equipment, or you have a wire through which a current is passing, it will have a electromagnetic field around it. So अगर आप कंपस के पास कोई भी एक इलेक्ट्रॉनिक इक्विपमेंट लगाते हो, एंटीना लगाते हो या वायर्स केबल्स पास करते हो, then you have to maintain that difference from the compass, because जब भी वो इक्विपमेंट वर्क करेगा, एंटीना ट्रांसमिट या रिसीव करेगा या केबल में से करंट पास होगा, तो इलेक्ट्रोमैग्नेटिक फील्ड जनरेट होंगे which are going to disturb our compass. So that is why that compass safe distance.
Okay, sir. Thank you.
सर, ये जो मास्ट आपने कहा, कल आपने बताया था कि मास्ट जो है वो सॉफ्ट आयरन में आता है, सॉफ्ट में आता है. आज अगर उसे भी तो वेल्डिंग करना पड़ता है, जब मास्ट लेके आते हैं लगाते हैं, So that won't become a permanent magnetism after that.
Beta, as I told you that we always go for the predominant property. Now, in the mast or funnel or vertical stiffeners, major portion is basically the amount of working upon is very, very less. Most of the items are prefabricated and fitted. So that is why it falls under the category of a soft iron.
Got my answer. Okay. It depends on the duration basically on which it is being worked on.
Yeah, the duration will also play its part. Okay, moving ahead. Now we have understood that depending on the heading of the ship and the hemisphere in which the ship is built, the positioning of the permanent pole could result in any oblique direction. The permanent magnetism vector could be present in a three-dimensional orientation. You can understand it from this particular diagram. We have this particular ship here, and the permanent magnetism is represented by this oblique slanting vector. This vector represents the permanent magnetism of the ship. One of the poles is on the deck towards the port quarter, and other pole is at the keel towards the starboard bow. So this vector represents the permanent magnetism of the ship. Now to counter this permanent magnetism, to rectify it, to correct it, this permanent magnetism in any oblique direction is split up into three mutually perpendicular directions. We resolve it, or we split this oblique vector in three mutually perpendicular directions. One of the component is split in the fore and aft direction. You can see this is the component in the fore and aft direction. This is known as the fore and aft component of the ship's permanent magnetism, and it is represented by alphabet P, Papa. Then you see this second vector, this is the second component. This is the authwardship component of the ship's permanent magnetism, and it is represented by Q, cubic. And the third component is the vertical component. You can see this particular arrow shows the vertical component of the ship's magnetism. This is known as the vertical component, also called as the healing component, represented by alphabet R, Romeo. Now, why are we breaking it up into three vectors like these? This is because it is very difficult to counter the permanent magnetism in an oblique direction in any 3D orientation. But when you split it up in three mutually perpendicular directions, that is fore and aft, authwardship, and vertical, it becomes easy for us to counter all these three components one by one. When we do the compass correction, we will see how this fore and aft component is corrected. Then we will see how this authwardship component is corrected, and we will also see how the vertical component is corrected. Clear up to here, beta? Great, let's move ahead. Now coming to the concept of compass work. Correcting a compass is also known as compass work. So what is the concept behind it? Permanent magnetism and induced magnetism both cause deviation of the magnetic compass. Now, as I told you, if our magnetic compass is affected solely by the magnetic field of the Earth, it will give us precisely the magnetic directions. Once you have the magnetic directions, you can apply the variation. Variation can be easily picked up from the chart and applied. And once applied, it gives you the true directions. But if you have the magnetism of the ship, permanent or induced, it will disturb our compass, and that disturbance is known as deviation. The permanent magnetism can be easily understood by considering its three components or by breaking it up into three components. That is the P component, which is in the 4.5 direction, this one. Then the Q component, which is in the outward shift direction, and the R component, which is in the vertical direction. So once you understand these three components of the permanent magnetism, we can cancel it or counteract it one by one. Moving ahead now. The induced magnetism can also be generated in three different directions. It can be broken up into three different directions. You can have the induced magnetism generated in the fore and aft direction. In fore and aft horizontal soft iron. That could be a fore and aft longitudinal. This is one orientation in which induced magnetism can be generated. Induced magnetism can also be generated in the outward shift direction. In outward shift soft iron, which could be the transverse or the outward shift beams. And it can be generated in the vertical direction, which happens in vertical soft iron. Examples of vertical soft iron are masts, cranes, or funnels, or vertical stiffeners.
So for a few seconds, can we go to the previous slides?
Okay, beta. Here it is.
Sir, in case of induced magnetism, they don't have any specific numbering or naming, like PQ and R for permanent magnetism.
In soft iron, they have a concept of rods. There are total 9 rods. So depending upon the orientation, they give it a name. But those rods were required when numerical portions were there. Now you will not need to memorize those rods.
Okay, sir. That's not in the portion right now, right?
Yeah, it will not be required in any concept.
Okay.
Sir, we will have numerical on.
No, beta. Numericals are not in syllabus in magnetic compass, but there are questions which involve practical concepts. So थोड़ा बहुत उनमें numerical चीज आ सकती है. Slight little bit of numerical. No formulas, nothing. No complicated numericals are there.
Okay.
सर इसके बाद वाला स्लाइड दिखा दीजिए.
Okay, beta. So this is yet to be done. Now each of these components has to be treated separately. You see, permanent magnetism, 3 component, fore and aft component, outward shift component, vertical component, and induced magnetism in fore and aft structures, horizontal fore and aft structures, induced magnetism in horizontal outward shift structures, and induced magnetism in vertical structures. They all have to be treated separately. There are 6 total components of the ship's magnetism which affect our compass. They need to be treated separately as the deviations which they generate varies with change in heading, change in latitude, and change in hemisphere. When the heading of the ship changes, it is possible out of these 6, some of the vectors, some of the components may be changing, whereas some may remain fixed or constant. It may happen with change in latitude also, it may happen with change in the hemisphere also. So since all of them are changing differently from each other, they have to be compensated differently in such a way that as and when the components of the magnetism change, our correction also changes in the same way. Because whatever correction we do to our compass, that correction should be able to cancel out these components in any condition. If the ship is heading in a fore and aft orientation, the fore and aft longitudinal is the most powerful. It is magnetized by the Earth's magnetic field. So we should have a corrector which should be able to judge this and provide a correction in the fore and aft direction of the same amount. Now when the ship goes to a easterly course, the fore and aft longitudinal loses its entire magnetism. Induced magnetism is lost. So our corrector should be such that it senses that the fore and aft longitudinal has now become powerless, and the correction which it was providing is also brought to zero. So we need a correction mechanism for each of these components, treating them separately, and it should be such a mechanism which keeps on changing its correction depending upon the change in the permanent or induced magnetism of the ship. This is what we call as component, the compass work. Now for treating these components, the deviation of the compass is divided into 5 different parts which we know as coefficients. So as I told you, we need to tackle these components separately one by one. So therefore, how do we tackle them differently? By dividing the deviation of the ship into 5 different parts. These parts are known as coefficients. Now, what are these coefficients? These coefficients are named as A, B, C, D, and E. The first 5 alphabets, A, B, C, D, and E. This is how the coefficients are named.
Sir, one thing, may I ask?
Go ahead, beta.
Sir, in the previous slide, it was asked that 6 components. So 3 components of the permanent magnetism and 3 components of the induced magnetism. Correct, sir?
Right, beta. Right.
Okay, sir. Yeah.
And here you are 5. That is the doubt, beta. There they were 6, and here you have only 5. Is that the doubt?
Yes, sir. And in this, in the slide, it was said that longitudinal component get cancelled. वो part.
Okay, beta. Okay, I'll tell you. बेटा जो हमने पहले 6 फैक्टर देखे थे ना, that is permanent magnetism 3 parts, P, Q and R. These are basically 3 vectors or 3 forces which generate deviation. And जो हमने vertical soft iron में देखा, that vertical soft iron can be in the fore and aft orientation, outward shape orientation or vertical orientation. These are again 3 different forces which can generate the deviation. अब let us assume कि इन सारे के सारे फैक्टर्स की वजह से हमारे कंपास में डेविएशन जनरेट हो गई है, एंड दैट डेविएशन इज 10 डिग्रीज, राइट? These were the causes of the deviation. All 6 factors, they have generated a 10-degree deviation. Now out of that 10 degree, we need to separate the different deviations. Now how do we separate it? We separated the properties of the deviation. Now, out of that 10 degree, it is possible that 1 or 2, let us say 1 degree, may be constant deviation throughout. The ship goes on any heading and that deviation does not change. So that falls under category of coefficient A. There could be some amount of deviation which only generates when the ship is on north or south headings. That falls under coefficient B. There could be a deviation which is generated when the ship is on a easterly or westerly heading. That falls under coefficient C. So these A, B, C, D, E are not the causes of deviation. They are the different parts of deviation which change differently basis the change in heading of the ship. This is the difference. Now, are you able to understand a little bit?
So A is constant, B is longitudinal, C horizontal, D is vertical. E is for what, sir?
D and E are both caused on intercardinal heading. Okay. हम इन सबको अभी डिटेल में करेंगे. व्हेन वी गो थ्रू देम इट विल कीप ऑन बिकमिंग मोर क्लियर बेटा. अभी के लिए बस इतना याद रखो कि जो परमानेंट और इंड्यूस्ड मैग्नेटिज्म के पार्ट्स थे, दे वर द फैक्टर्स विच वर कॉजिंग द डेविएशंस. जो ये हमने 5 कोफिशिएंट बनाए हैं, डेविएशन कॉज होने के बाद हमने उस डेविएशन को 5 हिस्सों में डिवाइड कर दिया है. कैसे डिवाइड किया है वो मैं अभी आपको बताऊंगा वन बाय वन.
Copied.
Go ahead with your doubts beta.
Sir, you just said that longitudinal, which is when in the orientation of north south, will have a strong magnetism, and when it is in east west orientation, it will lose its. This is the induced magnetism we are talking about, right?
Yeah,
Because
that's correct beta. That's
Okay.
correct. It is the induced magnetism. परमानेंट मैग्नेटिज्म को तो हेडिंग से फर्क ही नहीं पड़ेगा, बिकॉज
Yes, sir.
परमानेंट मैग्नेटिज्म के तो पोल्स जो हैं वो फिक्स्ड हैं.
Yes, sir. Yes. Thank you, sir.
ओके, बट परमानेंट मैग्नेटिज्म में भी एक और इम्पॉर्टेंट चीज है. नाउ यू गो लिटिल डीपर. परमानेंट मैग्नेटिज्म के पोल्स में तो कोई चेंज नहीं आएगा बेटा, बट हाउ इट अफेक्ट्स द कंपास will depend upon the heading of the ship.
Clear.
Okay.
Okay, sir.
Go ahead beta.
Sir, one small doubt, sir. What happens in case of rolling and pitching and all this? The induced magnetism will change, no?
Certainly beta.
Okay.
जब
So
भी
then how
कभी
do we?
rolling pitching. Okay, we will discuss about rolling pitching also. Because of rolling, a healing error is generated, and you must have seen practically on board that whenever the vessel rolls, heavy weather, the vessel is rolling, you see with every roll, when it goes on one side, the card swings in one particular direction. If it has a
Correct.
starboard roll, the card swings clockwise, tuck, 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 tuck. When the vessel
Yes, sir.
rolls to the opposite side, the card swings in the opposite direction. So the compass starts to oscillate very frequently. Okay, so that we will
Yes,
discuss later when we go to the healing error of the compass. So then I'll tell you that.
So, but does that affect the induced magnetism in a soft iron?
It will affect beta, because you see when the ship is perfectly horizontal, let us say you have a outward ship beam or a fore and aft longitudinal, it is perfectly aligned with some magnetic field line. When you are rolling,
Correct.
you see it is getting misaligned for some time, getting aligned again, misaligned. So the induction is going to vary. Sometime it will be more, sometime it will be slightly less, that way.
Okay. Clear.
Okay, great. Let's move ahead.
Can you show the induced magnetism components like permanent के तो PQ आते हैं, induced के क्या थे सर components?
Okay बेटा, induced के ये वाले हैं बेटा. Induced magnetism can be present in fore and aft, horizontal soft iron, outward ship, horizontal soft iron, and vertical in vertical soft iron.
So more or less they are same as permanent only, but permanent में they are permanently there. इसमें they keep on changing.
Yes, the orientations are the same, but the induced magnetism strength of the poles or induction will keep on changing, whereas permanent magnetism, the strength of the poles will remain fixed.
But all orientation are the same only. Rest they will keep on changing as per the latitude and heading is of case option.
Yeah, that's right, beta.
Okay, sir. Got it.
Okay. Now, it must be clearly understood that these coefficients A, B, C, D, E are the deviations generated and not the forces causing the deviations. The forces which are causing the deviations are permanent magnetism of the ship, broken down into 3 components: fore and aft P, outward ship Q, vertical R, and the induced magnetism of the ship in HSI, horizontal soft iron fore and aft, in outward ship HSI, and in vertical soft iron. These are the forces which are generating the deviations. What we have now done is, let us say, to give you an example, the ship is on a particular heading and the deviation is 10 degrees east. Now this 10 degree east comprises of all these 5 coefficients in it. The coefficient A could be contributing 2 degrees, coefficient B could be contributing 5 degrees, coefficient C could be contributing 0 degrees, and so on. When the ship changes its heading, the contribution of all the coefficients may also change. Okay. Now, how are these coefficients made? This is very, very important to understand. How are these coefficients specified or made? These coefficients are broken up as per the forces causing them. So depending upon what force is causing it, we have divided it into categories. So this is something which is new for you. You have not studied this in the second mates level. So once you understand this concept of coefficients, then the entire compass correction will be very easy to handle. Let us say, for example, as I told you, a ship is having 10 degree east deviation at a particular heading. Now, out of which, let us say, 2 degrees of deviation is being caused by the magnetism of the ship in the fore and aft direction. The magnetism of the ship in the fore and aft direction. It may have a permanent component, which is P component. P component is the component of the permanent magnetic field of the ship in the fore and aft orientation. And it may also have some induced magnetism. Induced magnetism, let us say ship is heading in a northerly-southerly direction, and there is a induced magnetism in the fore and aft longitudinal, and it may generate this particular deviation. So this deviation being generated by the magnetic field in the fore and aft orientation can be categorized as coefficient A. I've just given you an example how the deviation is broken up into 5 parts. So basis its causing factors, the deviations are broken up into different parts. If we know all the coefficients, the total deviation can be calculated on any particular heading of the ship. If we know the coefficients of a particular compass, let's say you go on a ship and I tell you that these are the 5 coefficients. Coefficient A is this much, coefficient B is this much, coefficient C is this much, and so on. Once I tell you all the coefficients, it is very easy for us to calculate the total deviation generated. Now, how can it be done? We have a very simple formula for finding the deviation from the coefficients. The formula is deviation is equal to coefficient A plus B sine course plus C cos course plus D sine twice the course plus E cos twice the course. This is a very, very important formula in magnetic compass, and it helps you to understand the basic fundamental behind the coefficients. How does it help to understand that? Just to give you an example, in this formula, if you see, coefficient A is not connected to the course at all. The contribution which coefficient A is providing to the deviation of the ship is not connected with the course. So what does this tell you? This tells you that this particular coefficient is independent of the course of the ship. The ship may be on northerly heading or easterly, southerly, westerly, any heading. The contribution of coefficient A is going to remain the same. Let's try to discuss or try to analyze the coefficient B also. Now, if you look carefully, B, coefficient B, its contribution to the deviation is given by B sine course. Now, if the ship is on a northerly heading, the course is 0, 0, 0. The value of sine 0 is 0. So that means the contribution of coefficient B on northerly heading is nil, 0. What if the ship goes on a easterly heading? On a easterly heading, the course becomes 90. Sine of 90 becomes 1, which is the maximum value, and the contribution of B towards the deviation becomes the maximum. So contribution to the deviation because of coefficient B is 0 on northerly heading. In fact, also on southerly heading, sine 180 is also 0. So contribution of coefficient B in the deviation is 0 on north and south headings, and its contribution in the deviation when the ship is on east or west heading is maximum. And the maximum value of this contribution to the deviation is also the value of coefficient B. Similarly, if you look at C, it is proportional to, or the contribution is proportional to cos of course. Now cos of 0 is 1. It means the contribution by coefficient C will be maximum when the ship is on northerly heading, and cos of 90 is 0. When the ship is on easterly course becomes 90, cos 90 becomes 0, and the contribution of C becomes 0. So contribution of C is maximum on northerly heading, and contribution of C is 0 on easterly heading. So this is how, looking at the formula, you can get an insight into the contribution made by all these coefficients in the total deviation at any particular heading. This is the concept of the coefficients and also the concept of the compass correction. Once you have understood this, it becomes very, very easy to understand the fundamental or the procedure of correction of the compass. The correction of the compass is basically counteracting these coefficients one by one. And this is what we will be doing further. We will be understanding these coefficients, what are the causing factors behind these coefficients, and then we will be seeing how can we counteract or cancel out these coefficients so that the deviation remains minimum possible.
Sir, may I?
Go ahead with your doubts, beta.
Sir, course is understood, sir. But how the position of the ship in which hemisphere will affect this formula?
See, beta, the position of the ship is going to affect the generation of induced magnetism.
Yes, sir.
Okay. And how that induced magnetism affects us, when we go into these coefficients, we will see which of these are affected with induced magnetism. Some of them are affected with permanent magnetism. So when we go into each and every coefficient, we will see with which permanent or induced part of the ship's magnetism it gets affected. So we will discuss that when we go into each and every one.
Yes.
So any more doubts coming up to here, beta?
No, sir.
Okay, all right. So now what we will be doing is we will be going into these coefficients one by one, starting with coefficient A, and we will be discussing them in detail. You get questions in your exams on explaining all these coefficients. So you may get a full-fledged question, 25 marks, explain coefficient A of the ship, or explain coefficient Bravo or Charlie or Delta or Echo. So you need to make a diagram. We make a deviation diagram for all these coefficients and then explain that diagram, explaining how is the deviation generated and what is the effect on compass, on the directive force. So that is what we are going to see now for all these coefficients. Okay, so I'm closing down this presentation. We are moving on to the next one. Okay, now beta, are you ready to jump into coefficient A or you want a short break?
A break.
Okay,
Sir,
so
after
let's take
A, we can take. After A, we can take, no? It's going to take a long time.
No problem. Take a 5 minutes break and be back.
Okay, sir.
Okay. Okay, beta, are we back?
Yes, sir.
Okay, so let's move on to the first coefficient, beta, coefficient A. So let me put up the presentation. Let's now go into our first coefficient, that is coefficient A. Coefficient A is a deviation which remains constant in name as well as magnitude on all the headings and is further divided into two parts. These two parts are number one, real A, and number two, apparent A. Now, if you remember the formula which I had shown you, the formula for deviation, in that formula we saw that this coefficient A is not connected with the ship's course in any way. Indirectly, that means that whatever be the course of the ship or whatever be the heading of the ship, the value of coefficient A is not going to change. And you see exactly that is what the definition also tells us. Coefficient A is a deviation which remains constant in name as well as magnitude on all the headings. The vessel can continue to change its heading, and the deviation which is generated because of coefficient A does not change at all. It has two components, and it can be divided into these two components. One is called as real A, another is called as apparent A. What is this real A part of the coefficient A? It is a constant deviation on all the headings caused by induced magnetism in unsymmetrical pairs of horizontal soft iron. I will explain this to you in detail by showing this kind of structure in the diagram. So for now, just understand it is caused by induced magnetism in unsymmetrical pairs of HSI, horizontal soft iron. So the cause of real A is the horizontal soft iron on board. The second part, which is called as apparent A, apparent A is a constant deviation on all the headings, which is caused by factors other than the magnetic field. Moving ahead now, beta.
Sir,
Go ahead, beta.
Only horizontal soft iron, sir. Nothing really about hard iron, sir.
No, beta, no. This coefficient A is only generated by induced magnetism, and that too only in horizontal soft iron.
Copied.
So what is meant by unsymmetrical pairs of HSI?
Okay, I'll show you that beta with the diagram.
Sir, it is not caused by permanent magnetism also.
No, there is no permanent magnetism involved in coefficient A beta.
Oh.
Okay, let me show you with the diagram now. Let me now show you the kind of structures which may generate coefficient A on a particular ship. Now we have seen that coefficient A is generated because of unsymmetrical pairs of horizontal soft iron. Now horizontal soft iron HSI can be present in two orientation. We can have a fore and aft horizontal soft iron, something like this one. This is horizontal soft iron in the fore and aft direction,
And we can also have horizontal soft iron in the outward ship orientation. You now see another horizontal soft iron which has a outward ship orientation. So the first thing to note is that coefficient A require a pair. Pair means there should be a combination of fore and aft as well as outward ship horizontal soft iron. The second thing which is required is that these horizontal soft iron should be unsymmetrical. Now, what do we mean by unsymmetrical? If you look closely, the fore and aft HSI which we have is present only forward of the compass location. The circle which you see in the middle of the ship is representing the compass, the binnacle, and the HSI in the fore and aft orientation is only present forward of the compass and it is not there aft of the compass. This kind of a HSI is known as unsymmetrical HSI. Likewise, this outward ship HSI which you see is present only on the port side of the compass and it is not present on the starboard side of the compass. So both these HSI are unsymmetrical. That means they are present only on one side of the compass and there is a pair present, means both fore and aft and outward ship HSI are present. This kind of a combination, if it is present on a ship, will generate coefficient A. Now, usually we do not see any kind of these structures on a normal merchant vessel. You will always have symmetrical HSI. So that is exactly the reason why coefficient A is absent on most of the normal merchant vessels.
Sir, can you please explain this again? I did not get it. Why we don't have it on board, the coefficient A?
Because beta on board whatever soft iron is present, it is always symmetrical. If you have a horizontal soft iron on port side of the compass, you will have it on starboard side also. If you have a longitudinal forward of the compass, you will have it aft of the compass also. The longitudinals and the beams, they extend from ship side to ship side, forward to aft. So what we require for coefficient A is unsymmetrical HSI, which is absent on a normal merchant vessel.
Okay, sir. Clear.
Okay.
Clear.
Okay. Now let's try to understand if we have such a configuration of horizontal soft iron on board a ship, so these kind of structures are present, how do they result into a real A coefficient? Or in other words, how do they generate a deviation which is constant irrespective of the heading of the ship? Whichever heading the ship goes, the deviation generated by these structures remains constant and does not change. So let us try to understand it. Now this is understood by making a deviation diagram. For every coefficient, we will be making a deviation diagram like the one you see on the screen now. We have the ship on different headings: north, northeast, easterly, southeast, south, southwest, westerly, and northwesterly. So cardinal and intercardinal heading, the ship is shown on these 8 headings. And in each of these headings, we are going to analyze that how do these horizontal soft iron structures, it is an unsymmetrical pair of horizontal soft iron structures, they generate the deviation which does not change. So we will first try to understand how do these structures affect our ship, and second we will try to see that how does this effect remain same irrespective of the heading of the ship. So let's try to concentrate our attention with the ship on the northerly heading. The ship is on a north heading. You can follow the laser pointer. This is the diagram which we are going to see or understand in detail. Now the ship is on a northerly heading. We have these two soft iron structures, one a outward ship beam, which is only present on the port side of the compass, and we have a 4.5 longitudinal, which is present on the starboard side, only forward of the compass. It is not present aft of the compass. So we have combination number one, which we saw in the previous slide, a unsymmetrical pair of horizontal soft iron structures. You see this big blue color rectangle on top. This represents the north magnetic pole of the Earth. We are aware that the north magnetic pole of the Earth has blue polarity. And you see this red color rectangle at the bottom. This represents the south magnetic pole of the Earth, and we are aware the south magnetic pole has a red polarity. Now we know that the magnetic lines of force, they come out of the red pole and they go into the north pole. So the magnetic lines of force coming out of the red pole going into the blue pole. So in this particular diagram, you will see that the magnetic lines of force are going vertically upwards from the red pole to the blue pole of the Earth, going vertically upwards like this. Now with the magnetic field of the Earth going vertically upwards, it will affect both these structures. It will affect the 4.5 longitudinal also, and it is going to affect the outward ship beam also. Now first thing to understand is that these are soft iron structures, so they do not have any permanent magnetism. There is no permanent magnetism in these structures. But being soft iron structures, they can get induced by the magnetism or magnetic field of the Earth. Now the magnetic field lines are going vertically upwards. If you concentrate your attention to the outward ship beam, this outward ship beam is not oriented or aligned in the direction of the magnetic field. It is at right angles to the magnetic field of the Earth. And if you remember during induced magnetism, I told you that there is minimum induction or zero induction, negligible induction, when the soft iron structure is misaligned with the inducing field. The inducing field in this direction is in the north-south orientation, and this outward ship beam is in the east-west orientation. The vessel is heading north, so the beam is in east-west orientation. So this beam is at right angles to the inducing field or the magnetic field of the Earth. Now being at right angles, no induction happens. No magnetic field induction happens here, and the outward ship beam does not acquire any magnetism. There are no poles which are generated. Let's now concentrate our attention to the 4.5 longitudinal. The 4.5 longitudinal, if you look carefully, is aligned exactly in the same direction in which the Earth's magnetic field lies. The magnetic field lines are in the north-south orientation. The 4.5 longitudinal is also exactly in the north-south orientation. So the 4.5 longitudinal is perfectly aligned with the magnetic field. And this tells us that there will be maximum induction in the 4.5 longitudinal. Maximum induction. So we know the 4.5 longitudinal having maximum induction will become a strong magnet now. Let us now understand the direction of the poles which are generated. We see the magnetic field lines are coming out from the red pole of the Earth and going into the blue pole. So this tells us that these magnetic field lines will be entering into the aft end of the longitudinal. If they are entering into the aft end of the longitudinal, wherever the lines of force enter, that end gets a blue polarity. Wherever the magnetic lines of force are entering, that end of the magnet has a blue polarity. So that's why you see the aft end of the 4.5 longitudinal has a blue magnetic pole. And these lines of force going from south to north will be coming out from the forward end of the longitudinal, the forward end. Since they are coming out of the forward end of the longitudinal, you will see that the forward end of the longitudinal acquires red polarity. So this is the reason why you see in the diagram, the aft end of the longitudinal has blue polarity and the forward end of the longitudinal has red polarity. So we now understand the different poles generated on the fore and aft longitudinal. Any doubts up to here, beta?
Yes, sir.
Go ahead.
Sir, for A, like 3 points which I understood. First, it is constant. Second, no involvement of permanent magnetism. Third, unsymmetrical pair of horizontal soft iron, sir.
Right, beta. That's correct.
But sir, like in this diagram, sir, we are understanding like in northerly and southerly, it is red and blue only in vertical direction. No effect in outward shift. And in northeasterly, it has component of both forward aft and outward shift.
Right, that's right.
But these things are not affecting the component of A. So हम लोग बेसिकली इसको सीधे सीधे ऐसे क्यों नहीं रट ले रहे हैं सर कि ये A कांस्टेंट रहेगा?
नहीं बेटा, पर A कांस्टेंट कैसे रहेगा वो देख रहे हैं ना आप, क्योंकि जैसे जैसे शिप की हेडिंग चेंज हो रही है, हमारे सॉफ्ट आयरन की ओरिएंटेशन भी चेंज हो रही है. सो ओरिएंटेशन चेंज हो रही, पोल्स की स्ट्रेंथ भी चेंज हो रही है. सो इतना सब चेंज होने के बाद भी कोफिशिएंट ए कांस्टेंट कैसे है? दैट इज व्हाट वी आर गोइंग टू सी नाउ.
ओके सर, मतलब अभी देखेंगे हम लोग क्यों कांस्टेंट है.
हाँ, अभी मैं आपको बताऊंगा. वी विल गो टू ईच ऑफ दीज हेडिंग्स वन बाय वन एंड आई विल टेल यू इन डिटेल हाउ दिस डेविएशन इज जनरेटेड एंड व्हाई इट रिमेन्स कांस्टेंट. ओके, अभी मैं नेक्स्ट डायग्राम में आप देखोगे, आपको क्लियर हो जाएगा.
सर, वन डाउट.
या, गो अहेड.
सर, दिस कोएफिशिएंट A, this real A will always be easterly deviation.
No, it can be westerly also, beta. There can be a slight difference in the structures. It can be westerly also. In this particular example, it is easterly.
Because as I'm seeing in the north heading, अगर दोनों opposite में हो, जैसे longitudinal port side में and this outward shift one on the starboard side, then it will be on the westerly.
Exactly, beta. That combination
is
also possible.
Specific for this only, this diagram.
Right, that is correct.
Sir, this black arrow is the deviation.
The black basically represents the magnetic compass, and you can see it is slightly deviated to the easterly direction, so that represents easterly deviation.
Okay, sir. So in all headings it is easterly deviation.
Yeah, that's correct, beta.
So this compass which is shown in this diagram, it easterly deviation, it is nothing related to A right now.
It is generated because of coefficient A only. How it is generated, मैं अभी explain करता हूँ. Now we have understood the induction or induced magnetism of the horizontal soft iron structures by the Earth's magnetism. Let's now try to see that at different headings, what is the deviation which is generated because of this induced magnetism. So as you can see in the diagram, at every heading, they indicate to us that it is a easterly deviation. You see north heading, northeast, easterly, southeasterly, southerly. On all the headings, they are denoting that the vessel has a easterly deviation. And in the definition of coefficient A, we have seen that it generates a constant deviation irrespective of the heading. So we will try to see now how does this deviation remain constant over all the headings. Let's first of all try to understand how this easterly deviation is generated with the ship on northerly heading. So what I'm going to do is I'm going to zoom in into this diagram with the ship heading north, We are aware that we have a fore and aft longitudinal and a outward ship beam. There is no induction on the beam right now because it is at right angles to the Earth's field, and there is maximum induction in the fore and aft longitudinal. So let's now try to zoom in into this. So here on the left side, you see a zoomed in diagram with the ship heading north. Let's first make the magnetic compass on this ship. Now we know the magnetic compass is basically a magnet, and the end which points towards the north is the red end of that magnet. So let's show our magnetic compass. You can see it here. The north end of the magnetic compass is having a red polarity. You see the red color, and the south end is having a blue polarity. So this arrow which you see in the zoomed in diagram of the ship now represents the magnetic compass. And we have a longitudinal which is to the starboard side of the compass, and it is forward of the compass location. It is not present aft of the compass location. So you can see this longitudinal in the zoomed in diagram now, and it is to the starboard side of the compass and is extending to forward of the compass. Now we have already seen that this particular end, the aft end of the longitudinal, acquires a blue pole, and the forward end of the longitudinal acquires a red pole. This is a soft iron structures, and these poles are acquired as induced magnetism, which are generated by the magnetic field of the Earth. Now, whenever we bring a magnet close to our compass, every magnet has two poles, a red and a blue pole. We cannot have a single pole in a magnet anywhere. Even if you break up a magnet, the broken ends immediately acquire the polarity. You cannot have a single pole at any point. Now, whenever you bring a magnet close to the compass, it has both the poles, the red as well as the blue. Now, which of the poles is going to affect the compass? Always, in all the conditions, that poles affect the compass which is closer to it. Because as you go far away from the pole, the magnetic field or its strength or its power reduces. It is inversely proportional to square of the distance. Means if you increase the distance by twice, the magnetism or magnetic field strength of the pole goes down by 1/4. So whenever you bring a magnet close to the compass, that particular pole which is closer with respect to the other has its effect on the compass. Now in this particular case, the longitudinal is having two ends. One of the ends is very close to the compass, which is having a blue polarity, whereas the other end, for clarity, I have exaggerated a bit and taken it out of the ship's hull. So the other end of the longitudinal is close to the bow of the ship, which is much farther away as compared to the blue pole. So in this case, blue pole is the one which is going to have its effect on our magnetic compass. Now, how does this blue pole affect our compass? The effect of this blue pole onto the red end, that is the north end of the compass, will be attraction. Because we are aware that opposite poles of a magnet attract each other. So this blue pole of the fore and aft longitudinal is going to attract the north end of our magnetic compass or magnetic needle. So when it attracts the north end towards it, the compass is going to deviate to the right side. Looking at the diagram, it is going to deviate to the right side, and that is easterly side. With the vessel heading north, the right side is easterly direction, so a easterly deviation is generated. Also, you can see this blue end is also going to interact with the south end of the compass. The south end of the compass also has a blue polarity. Now we know that the same poles of the magnet repel each other. So this blue pole of the longitudinal is going to repel the blue pole or the south end of our magnetic compass, again generating easterly deviation. The compass needle is going to swing clockwise, which is easterly deviation. So that is why you see they have mentioned here as easterly deviation. Up to here, any doubts coming in, beta?
No, sir. Sir.
Go ahead.
This arrow one is the ship's magnetic compass, we can say, sir.
Yeah, that's correct, beta. The magnetic compass, I have colored the poles, red pole towards north and blue pole towards south.
And the right side, which these balls represents, these are the horizontal soft iron induced magnetism.
Yes, this is the HSI which is fitted on the ship, and the blue and red ends are the poles generated on that HSI because of the Earth's magnetic field.
Yes, sir. Sir, how we can say it will be on the starboard side, not on the port side, or it is the total component of the...
Okay. You mean to say that this structure is only on the starboard side and not on the port side? Why it is so?
Yes, sir. क्योंकि अभी पढ़े the ship, our ship is symmetrical ना sir.
That's correct, beta. But as I told you कि ये जो coefficient है ये तभी generate होता है if there is a unsymmetrical soft iron. So it is present on the starboard side. It is not present on the port side. Okay.
Always, sir.
If it's present on the starboard, this port side, then it will be westerly deviation, correct?
Right. If it is present on the port side, then the deviation is going to be westerly. And अब एक और डाउट आपके माइंड में आएगा कि हमारे शिप पे तो जनरली सिमेट्रिकल HSI प्रेजेंट होता है, वो सिमेट्रिकल HSI भी आगे आएगा, but that falls under coefficient delta. So when we go to delta, I will make symmetrical HSI and we will see the deviation then.
Yes.
Okay. यहाँ पे हमने सिर्फ एक एग्जाम्पल ली है जिसमें हमने ये अनसिमेट्रिकल सॉफ्ट आयरन इस पर्टिकुलर ओरिएंटेशन में लिया है. So that is just an example, beta. Practically, you will not see this coefficient on board. It will be absent.
Copied. So this is just a circumstance we are taking. It is easterly to us.
Right. अब एक और डाउट आपके माइंड में आ सकता है कि अगर ये एक्चुअल शिप में नॉर्मल मर्चेंट वेसल में होता ही नहीं है तो हम इसे डिस्कस क्यों कर रहे हैं? दैट इज बिकॉज नंबर 1, हमें 25 मार्क्स लेने हैं MMD में अगर ये क्वेश्चन आता है. एंड नंबर 2, बेटा जो स्टडी है मैग्नेटिक कंपस की ना, it basically analyzes all the possibilities. Whether it is present on a ship or it is not present, it analyzes all the possibilities, whatever can be there. So that is why all these things are included. आगे भी कुछ एक coefficients ऐसे आएंगे, जैसे induced C coefficient एक आएगा, फिर उसके बाद eco coefficient आएगा, वो भी normal merchant vessel पे absent होते हैं, but we will study them because number 1, the questions come in the exam, and number 2, the study is complete all the possibilities. Okay, बेटा?
वो तो सर पूरे स्टडी सिस्टम पे ही लगता है. We are studying.
Yeah, that's right. Okay, और बताओ बेटा, और doubts?
Sir, in this force of attraction. Sir, in this force of
from
attraction
exam point of view.
One by one. Exam point of view, बोलो बेटा, बोलो.
Sir, from the exam point of view, these unsymmetrical soft ions, they would be mentioning in the question, right? So in what orientation and how it will be, and then we have to draw.
No. They will only ask you to explain coefficient alpha. So वो coefficient A बोलेंगे, ये entirely आपकी choice है कि आप कैसा combination लेना चाहते हो, but you cannot pick up any random combination. It has to be a particular combination. मैं आपको अभी 4 possibilities इसकी बाद में दिखा दूंगा जिनमें ये generate हो सकता है. Okay? उन चारों में से कोई भी एक आप पिक कर सकते हो, बट बुक में अगर आप रेफर करोगे या नोट्स में देखोगे तो सिर्फ ये वाला जो कोफिशिएंट है, दिस इज एक्सप्लेन्ड इन डिटेल.
So you can just pick up this one and explain it.
ओके सर, जैसे अगर फॉर एग्जांपल ये अनसिमेट्रिकल को हमने रिप्लेस कर दिया एक दूसरे को, तो वेस्टर्ली डिविएशन हो जाएगा, तो दैट वोंट बी रॉन्ग, राइट? इफ यू डू इट इन द एग्जाम,
दैट वोंट बी रॉन्ग, दैट वोंट बी रॉन्ग। बट अगर आप इसे पोर्ट साइड में लेके जाते हो फॉरवर्ड ऑफ द कंपास, तो फिर ऑर्थवर्ड शिप बीम आपको स्टारबोर्ड में लाना पड़ेगा आफ्ट ऑफ द कंपास।
आफ्ट ऑफ द कंपास,
So technically we have to reverse all of them, no?
राइट, यू हैव टू रिवर्स ऑल ऑफ देम देन। ओके, मैं आपको अभी दिखा दूंगा कॉम्बिनेशंस जिनमें ये पॉसिबिलिटी है। देयर आर टोटल 4 कॉम्बिनेशंस वेयर दिस इज पॉसिबल।
Okay, sir. So the easiest one is just if they ask about real A deviation, then we just pick up this one and draw it.
Yeah, exactly, beta. Do that.
Okay, okay, sir.
Next out, beta.
Sir, in this force of attraction and repulsion is same only, no?
Yeah, that's correct. The blue pole of the longitudinal is attracting the red end of the compass needle and repelling the blue end of the compass needle, swinging it clockwise, looking from top, and generating a easterly deviation.
Okay, sir. So in the coming coefficient also, so it will be same only, like all this forces.
It may vary slightly. We will see another situation, beta. अभी देखेंगे.
ठीक है.
Okay. चलें बेटा, next heading पे देखें.
Yes.
Okay, let's go. Let's now take the ship on a easterly heading and understand the deviation generated. Now on the easterly heading, we can see that the fore and aft longitudinal is now at right angles to the magnetic field of the Earth. The Earth's magnetic field lines coming out from the red pole going into the blue pole are going vertically upwards. The fore and aft longitudinal is at right angles, so no induction is generated on the fore and aft longitudinal. On the other hand, the outward ship beam is now perfectly aligned with the magnetic field of the Earth, thus generating maximum deviation. So let's now zoom into the easterly heading diagram and see the effect in detail. You can see the outward ship beam shown in the diagram. I have taken the outer end slightly outside the ship structure to make it more clear and easy for understanding. The fore and aft longitudinal is not shown in the diagram because there is no induction and no poles are generated. Now magnetic field lines are entering into this particular end, the south end of the outward ship beam, giving it a blue polarity. Wherever the lines enter, the soft iron acquires a blue polarity, and the lines are coming out from the north end of the outward ship beam, giving it a red polarity. Now we have a blue pole to the east of the compass. The compass needle points in the north direction. Vessel is heading in the easterly direction. So this blue pole, which is to the east of the compass needle, attracts the red end of the compass needle towards it. The needle is pivoted at the middle at this particular point here. So it swings clockwise towards the blue pole shown by this arrow, generating a easterly deviation. Also, this blue pole repels the blue end of the compass needle, and this also adds on to the clockwise swing or the easterly deviation generated in the compass needle. So beta, any doubt in this easterly heading? Okay, great. Let's move to northeasterly heading now. Now let's see a third scenario with the ship heading in the northeasterly direction. So with the ship heading in the northeasterly direction, how does the deviation behave? Let's zoom into this diagram of the ship.
So on the left side, you see the zoomed in diagram of the ship. We have the compass as usual placed in the center line. Irrespective of what is the direction in which the ship is heading, the compass needle is always going to point north and south. The north end will be the red end of the compass and the south end will be the blue end of the compass. Now we have a longitudinal, 4.5 longitudinal to the starboard of the compass. So you can see on the starboard side we have a 4.5 longitudinal, which is only forward of the compass. It is not there aft of the compass. We also have a athwart ship beam. The athwart ship beam is forward of the compass and only to the port side. You can see the athwart ship beam is only to the port side of the compass. It is not present on the starboard side. Now I have taken the far ends of the longitudinal and the beam out of the ship's hull just to make the picture a little more clear and easy for understanding. Now in this case you see the Earth's magnetic field coming from south to north is going to induce both these structures, because both of these structures are now at a 45-degree angle to the Earth's magnetic field. They are neither fully aligned nor misaligned. They are partially aligned with the magnetic field of the Earth, so there will be partial induction on both these structures. That is the longitudinal as well as the beam. Partial induction on both of them. So the poles generated will have partial power. And now you look carefully. The blue pole is generated in the longitudinal as well as the beam. And this is the pole which is closer to our compass. The red poles generated are far away from the compass. So blue poles are the one which are going to affect our compass. Now the blue pole of the athwart ship beam is closer to the red end or the north end of the compass, and it is going to attract the compass towards it. Whereas the blue pole in the longitudinal is close to the south end of the compass, which is again blue, and both being the same polarity, they are going to repel each other. And you will see, even though there are two poles, they are both trying to swing the compass in the clockwise direction again. So you see, the compass has to swing clockwise again, generating easterly deviation. Now one doubt may arise that since there are two blue poles now, the deviation generated will be more powerful, but that is not the case. Reason being, even though two poles are generated, but both of them have partial power. Why the power is partial? Why their strength is partial? Because they are not perfectly aligned with the magnetic field of the Earth. Both the longitudinal and the athwart ship beam are partially aligned, making these poles partially powerful. So when both these poles add up, they generate the same easterly deviation which was generated on 000 heading and 090 heading. So you can see, irrespective of the heading on which the ship is, the deviation generated remains the same. So beta, any doubts coming up to here now?
सर
Go ahead beta.
हाँ सर, आपने अभी सर 3 सिचुएशन समझाया, मेरे को बस डाउट तभी आएगा अभी, ये जो सिचुएशन आपने हमें समझाया है कि एक रेड पोल यहाँ से यहाँ तक हम छोटे में देख रहे हैं तो छोटा दिख रहा है, बड़े में यू आर एक्सटेंडिंग इट, विल दिस बी अ कांस्टेंट सिचुएशन लाइक व्हिच वी नीड टू एक्सप्लेन, और दे विल मॉडिफाई समथिंग लाइक छोटा मैग्नेट दिया है तो रेड और ब्लू दोनों एकदम नजदीक नजदीक है तो हम उसको नहीं इमेजिन कर पाएंगे कि बाहर तक ले जाए, ऐसा कुछ चेंजेस होगा या
नहीं
दिस इज
बेटा,
स्टैंडर्ड लाइक?
कोई चेंजेस नहीं होगा. ओनली थिंग इज, जो राइट साइड में डायग्राम आप देख रहे हो ना, दिस इज द डायग्राम विच इज गिवन इन द बुक. इसमें बिकॉज ऑफ द साइज इन्वॉल्व इन्होंने क्लैरिटी नहीं दिखाई है. यहाँ पे इन्होंने लॉन्जिट्यूडनल का रेड एंड जो है वो भी कंपास के पास दिखा दिया है, बट इट शुड बी फार अवे फ्रॉम द कंपास, सो विच इज क्लैरिफाइड इन द zoomed in diagram. So you can make the zoomed in diagram straight away. You don't need to bother about small size or big size.
जैसे अभी मुझे आपने जैसे कहा कि कभी पूछा जा सकता है कोएफिशिएंट ए को एक्सप्लेन करो, तो जब मैं वो बनाऊंगा तो उस टाइम पे मैं थोड़ा बाहर भी ले जा सकता हूँ, राइट सर, रेड को थोड़ा लंबे या नहीं?
You can take it better slightly. Just mention there it has been taken outside the structure for clarity.
अच्छा सर, ओके.
Okay.
Noted, sir.
Or better would be you keep it close to the ship side. Okay. Keep it close to the ship
ये
side.
होगा कि स्ट्रक्चर शिप के बाहर गया कैसे?
राइट क्योंकि मैंने तो यहाँ आपको समझाने के लिए थोड़ी डायग्राम क्लियर करने के लिए उनको दूर रख दिया है, बट द एग्जामिनर हु इज चेकिंग द पेपर ही इज अवेयर अबाउट दिस, सो इवन इफ यू मेक इट लिटिल क्लोज ही विल अंडरस्टैंड.
इसी के लिए मैंने पूछा सर, ये स्टैंडर्ड है क्या? स्टैंडर्ड है तो फिर ही विल अंडरस्टैंड. ओके,
राइट, दिस इज अ स्टैंडर्ड थिंग. एनी कोफिशिएंट ए क्वेश्चन यू कैन शो दिस.
Sir, one thing.
बोलो बेटा.
This component which horizontal soft iron which we are taking, sir. So
right.
This longitudinal and horizontal, जैसे एक starboard है तो outward वाला सर little port side और इधर है. So अभी बीच में आप डिस्कस हो रहा था तो बताया कि if it is on the port side and forward, ये सर जो longitudinal वाला है वो पीछे भी तो हो सकता है थोड़ा अपने मैग्नेटिक कंपास से.
ओके बेटा, ओके. अब मैं आपको ना ये चार इसकी पॉसिबिलिटीज जो हैं वो दिखा देता हूँ. लेट मी शो यू, जस्ट गिव मी अ मिनट. Okay. Now, do you see these four possibilities now, four diagrams?
Yes, sir.
इनमें से जो पहली डायग्राम है, that is what we have discussed. You have a longitudinal starboard of the compass only forward. You have a outward ship beam forward of the compass only to the port side. ये हमने स्टडी किया है अभी डिटेल में. बाकी के जो तीन हैं ये भी कोफिशिएंट ए को जनरेट करेंगे. These are the four possibilities which are going to generate coefficient A.
Understood, sir.
इनको छोड़ के और भी बहुत सारी पॉसिबिलिटीज हो सकती हैं. और भी बहुत सारी पॉसिबिलिटीज हो सकती हैं. लाइक somebody can say कि भाई ये जो ऑथवर्ड शिप बीम आपने फॉरवर्ड ऑफ द कंपास बनाया है इसे आफ्ट ऑफ द कंपास बना देते हैं. बट अगर आप इन चार को छोड़ के कोई और पॉसिबिलिटी बनाओगे तो फिर वो कोफिशिएंट ए के स्कोप से बाहर चली जाएगी बेटा. So you have to make any one of these four, and the best would be to make the first one जिसकी डायग्राम हमने डिटेल में कर ली है.
Yes, sorry.
ओके. और बेटा
सर अगर
और
इस
कोई
केस
डाउट?
में जो पहली बार जो जिसपे आपने कर्सर रख रखा है अभी,
राइट,
जो आर्थवर्ड शिप वाली रॉड है आपकी, अगर वो स्टारबोर्ड में ले जाए और जो लॉन्गिट्यूडनल वाली है वो पोर्ट में रह जाए और फॉरवर्ड ऑफ द कंपास ही रहे, तो तब वो अनसिमेट्रिकल नहीं बनेगा?
बनेगा बेटा. इनका जो रिवर्स कॉम्बिनेशन है ना वो भी आपको कोफिशिएंट ए जनरेट करेंगे. ये बेसिकली प्लस वाले कोफिशिएंट यहाँ पे दिखे हैं, माइनस वाले वो जनरेट हो जाएंगे. So you can go exactly reciprocal of these also. Those four also will be added on.
Okay sir. Both like forward of the compass only, but वो आप कह रहे हो कि नेगेटिव में होंगे.
Right बेटा, right.
सर एक क्वेश्चन है सर, इसमें हर एक में नीचे माइनस डी प्लस डी वो क्या लिखा है सर?
ये बेटा जो मैंने आपको बताया था ना कि सॉफ्ट आयरन के जो स्ट्रक्चर्स हैं उनकी नेमिंग की जाती है फॉर 9 rods. So these are basically names of those rods.
वो रिमेम्बर करना सर जरूरी है?
No, not mandatory, not required for any understanding. You can leave it.
सर
बोलो बेटा.
अभी ये सर्कल में 8 पॉइंट्स है, 8 शिप के डायरेक्शंस आपने दिखाए हैं, तो आंसर जब लिखूंगा तो उस टाइम पे 8 पॉइंट्स को एक्सप्लेन करना है?
नहीं बेटा, not required.
कोएफिशिएंट ए अगर आते हैं तो
now you have to basically decide the length of your answer basis the marks allotted to it. अगर ये 25 नंबर का क्वेश्चन आ जाता है बेटा, 25 marks question, then certainly you will have to write at least 15-20 points. So फिर वहाँ पे आप इन सबको explain कर सकते हो. बट यही क्वेश्चन अगर 12.5 मार्क्स में आता है, so then you don't need to explain too much. Just writing a single line for 3 of the headings would be enough.
Got it, sir.
इसमें मैग्नीट्यूड सेम रहेगा डेविएशन का, ऑल हेडिंग?
Yes, it will remain the same.
ओके सर।
क्लियर बेटा, चलें आगे?
Sir,
go ahead, go ahead, beta.
in this figure, sir, in this when the vessel is facing westerly on a westerly heading, so can you explain that scenario how this how it will work? Because the outward ship rod will be parallel to, yes sir, parallel to the.
ठीक है बेटा, मैं व्हाइट बोर्ड पे बना के दिखा देता हूँ वेस्टर्ली हेडिंग पे. जस्ट गिव मी अ मिनट.
सर नॉर्थ वेस्टर्ली बता दो सर. वेस्टर्ली ठीक है, नॉर्थ वेस्टर्ली बता दीजिए.
Whichever you say, just give me a minute, I'll open up the whiteboard. Just a minute, beta. Looks like the screen is frozen. Okay, all right, started working. I hope you can see my screen now.
Yes sir.
Okay,
yes, sir.
so कौन सी हेडिंग लेना चाहते हो बेटा?
नॉर्थ वेस्टर्ली.
ओके, लेट्स टेक नॉर्थ वेस्टर्ली. ये हमने शिप को नॉर्थ वेस्टर्ली हेडिंग पे डाल दिया. लेट्स मेक द कंपस. कंपस का साउथ एंड जो है ये ब्लू है और जो कंपस का नॉर्थ एंड है वो रेड है. सो दिस इज आवर कंपस. अब ये दोनों स्ट्रक्चर बना देते हैं. लेट्स मेक देम इन ब्लैक. एक स्ट्रक्चर है जो कंपस के स्टारबोर्ड साइड में है, ओनली फॉरवर्ड ऑफ द कंपस. तो ये स्ट्रक्चर एक मैंने बना दिया. और जो ऑथवर्ड शिप बीम है दैट इज फॉरवर्ड ऑफ द कंपस ओनली ऑन द पोर्ट साइड. ये मैंने ऑथवर्ड शिप बीम बना दिया. अब यहाँ पे लाइंस ऑफ फोर्स आर गोइंग टू एंटर लॉन्जिट्यूडनल के इस एंड पे एंटर करेंगी लाइंस. सो यू विल हैव ए ब्लू पोल समवेयर हियर एंड ऑथवर्ड शिप बीम के इस एंड पे लाइंस जो हैं ये एंटर करेंगी. सो दिस विल हैव ए ब्लू पोलैरिटी. जो रेड पोलैरिटी आएगी, रेड पोलैरिटी विल बी हियर एट दिस पर्टिकुलर एंड and the second red polarity will be here at this particular end. So up to here okay beta?
Yes sir.
अब अगर आप ध्यान से देखो, let me pick up the black marker now. जो कंपस के ईस्ट में ब्लू पोल बन रहा है, that blue pole is going to attract the red end towards it, generating a easterly deviation. And कंपस के वेस्ट में जो रेड एंड है that is going to repel, again adding up to this easterly deviation. So दो पोल्स हैं, दोनों कंपस नीडल को क्लॉकवाइज टर्न कर रहे हैं, generating easterly deviation, and दोनों में partial induction है. So again you will have easterly deviation getting generated on this particular heading. So same deviation is generated.
Understood sir. Thank you.
Clear बेटा? और किसी हेडिंग पे बनाना चाहते हो?
No sir, thank you sir. Done.
Okay, all right. Great. So let's go back to the presentation. हाँ बोलो बेटा.
सर ये पूछना था कि जैसे कंटेनर शिप पे हम लोग कंटेनर लोड करते हैं बहुत सारे ऊपर डेक के ऊपर, सो
Okay.
दे अफेक्ट दैट मैग्नेटिज्म और द कंपास के लिए. because they are made of this iron or some ferrometric materials.
बेटा जितने भी शिप्स पे आप मैग्नेटिक कार्गोज लोड या अनलोड करते हो, यू कैन म्यूट योर माइक नाउ।
ओके।
जितने भी शिप्स पे आप मैग्नेटिक कार्गो लोड या अनलोड करते हो, it could be a container vessel, it could be a bulk carrier on which iron ore or any cobalt or nickel derivative is loaded or unloaded. It could be a roll on roll off ship जहाँ पे vehicles आते हैं और vehicles जो है वो offload होते हैं। ऐसे सारे ships में जब भी loading या discharging होगी तो आपके ship का जो magnetic effect है वो change हो जाएगा। So you will see the deviation card varying too much after every loading and unloading operation. So that variation is going to, sorry, the deviation is going to go for a toss after every loading and unloading. Okay. So strictly speaking, going as per the norms, after each loading and unloading operation, you have to make a new deviation card, but that's practically not possible, so not done. So you have to keep this thing in mind that every loading and unloading of a magnetic cargo is going to affect the deviation of the ship, deviation of the compass. Clear, beta?
ये जो रिक्वायरमेंट है रिगार्डिंग एनुअल इंस्पेक्शंस ऑफ डेविएशन कार्ड, why is it annual? मतलब why not 5 yearly or let's say 6 monthly? Why just annual?
Okay. See, beta, it is basically annual and then at every dry dock. Okay. Now dry dock is clear कि हर एक dry dock में कुछ ना कुछ steel renewal होगा. So whenever steel renewal happens तो ship का magnetism change होने वाला है. जो भी नया steel आप डालोगे उसका अपना induced या permanent magnetism add on हो जाएगा. So that's why whenever the ship comes out of a yard after every repair or dry dock, a new card is made. Now what happens is, beta, as time passes, the magnetism of the ship also changes with time. Depending upon कि ship कौन सी heading पे सबसे ज़्यादा रहा है, ऐसे तो heading change होती रहती है, but depending upon the if you have something which can measure the heading of the ship at every interval, and you can see for so many hours it was on this heading, for so many hours on this heading, all these things, they basically change the magnetism of the ship slowly. The change is very gradual. So to account for this gradual change, a deviation card is expected to be made every year so that any changes are accounted for. This is the reason, beta.
Thank you.
Okay.
सर एक डाउट और था।
बोलो बेटा।
कि रोलिंग और पिचिंग में तो ठीक हम लोग समझते हैं कि मैग्नेटिज्म का इफेक्ट नहीं है, बट जैसे भी हम लोग क्या होता है कि हैमरिंग करते हैं थ्रू दैट मेटल पे हो गया हल फ्लोरिंग को ज़्यादा बेंड करने के लिए, तो उसमें मैग्नेटिज्म का इफेक्ट होता है, मतलब वो मैग्नेट जो स्टील है वो परमानेंट मैग्नेट में या किसी मैग्नेट में कन्वर्ट हो जाता है। सो रोलिंग जैसे हो गया हैवली या पेंटिंग और पाउंडिंग स्ट्रेसेस हो गया, तो दे आर आल्सो एक्टिंग लाइक अ फोर्स ऑन दैट, सो डज इट मेक एनी इफेक्ट?
ओके, अब बेटा ये कोई सब्सटेंशियल इफेक्ट नहीं बना पाता है. इट इज नॉट एबल टू मेक ए सब्सटेंशियल इफेक्ट बिकॉज ये जो रोलिंग और पिचिंग हो रहा है, इट इज बेसिकली लाइक हैमरिंग ऑन द शिप्स hull. Now this is not happening on one particular heading. Sometimes the ship is on this course and it experiences bad weather. Sometimes it is on this course experiencing bad weather. So the ultimate changes which come, वो हम annual deviation card जब बनाते हैं उसमें account for हो जाते हैं. Okay beta, got it?
Sir, one doubt.
बोलो बेटा.
Sir, this what we have learned now, relay and all, that is only for main magnetic compass, right? What about lifeboat compass? I have never seen anyone doing deviation card and all for lifeboat compass. What about that?
Okay. So what is the doubt about lifeboat compass?
Like, is there like this athwart ship and all? Nothing, right? Because they are at the extreme outboard, right? Lifeboats, or else on the aft. So magnetic compass inside the lifeboat, right? So we will not have athwart ship, right? Only longitudinal.
Okay, you mean to say that now you are analyzing the effect of ship's magnetism onto the life port compass, right?
Yes, sir. Yes.
Okay. अब बेटा पहली बात तो ये है कि आपको इसे करने की ज़रूरत नहीं है. रीज़न फॉर दैट इज़ कि लाइफ पोर्ट कंपास जब हम एक्चुअली यूज़ करेंगे, द लाइफ पोर्ट इज़ गोइंग टू गो अवे फ्रॉम द शिप, so it will be free from the ship's magnetism when it is practically used. That is exactly the reason why there is no binnacle inside the life port. लाइफ पोर्ट में एक सिंपल कंपास फिटेड होती है, उसमें कोई बिनेकल नहीं होती और कोई करेक्टर नहीं होते. रीजन बीइंग लाइफ पोर्ट का जो स्ट्रक्चर है वो प्रिडोमिनेंटली ग्लास फाइबर और नॉन मैग्नेटिक मटेरियल का बना हुआ है. उसमें मैग्नेटिक मटेरियल सिर्फ एक ही है, दैट इज द इंजन, and that is also basically exactly below the compass. In most of the cases, the major portion of the engine is vertically below the compass, so it does not generate much deviation. This is the reason why there is no binnacle and no correctors fitted in the life port compass. अब बात आती है कि when the life port is stored in normal position, जब ये stored है normal position में, तो आपको life port compass कभी भी actual headings या magnetic headings नहीं बताएगी, क्योंकि वो छोटी सी लाइफ पोर्ट कंपास के एक साइड में पूरा का पूरा शिप आ गया है बेटा. ओके, जो स्टारबोर्ड लाइफ पोर्ट है उसके पोर्ट साइड में पूरा शिप स्ट्रक्चर है, और जो पोर्ट लाइफ पोर्ट है उसके स्टारबोर्ड साइड में पूरा का पूरा शिप स्ट्रक्चर है. सो द इफेक्ट ऑफ शिप्स मैग्नेटिज्म ऑन लाइफ पोर्ट कंपास इज वेरी लॉपसाइडेड, एंड इवन दोनों जो लाइफ पोर्ट्स हैं उनकी कंपास आपस में भी एक दूसरे के साथ मैच नहीं होगी, and both of them are not going to match with the compass on top. Okay, so this is about life port compass beta. Does that solve your doubt?
Yes, sir. Okay. What if we take this small magnetic compass near the binnacle on the Monkey Island? Then it should show some realistic value.
Yes, that can be done. आप इसे लाइफ बोर्ड से निकालो, मैग्नेटिक कंपास की लोकेशन पे इसे ले जाओ, then the headings should be more or less close.
Okay, sir. Thank you.
Okay, मैच ये तब भी नहीं होंगी क्योंकि दोनों कंपासेस के साइज में डिफरेंस है, तो करेक्टर्स की करेक्शन में भी डिफरेंस आएगा, सो एग्जैक्टली मैच फिर भी नहीं होंगी.
सर एक डाउट पूछना था.
बोलो बेटा.
जैसे सर ये जो लाइव बोर्ड का कंपास रहता है तो हम लोग ड्रिल के टाइम पे मैच करते हैं कि मतलब कितना दिखा रहा है, व्हाट इज द हेडिंग, तो उसमें कुछ डेविएशन का मतलब वेरीज है कितना होना चाहिए, अप्रोक्सीमेटली कितना रहेगा, प्लस और माइनस फ्रॉम.
बेटा वो बहुत ही वेग कंपैरिजन है, दिल की तसल्ली के लिए गालिब ये ख्याल अच्छा है. सो लिखने के लिए आप मैच कर सकते हो, बट एज आई टोल्ड यू कि शिप का पूरा स्ट्रक्चर वो छोटी सी कंपास के एक साइड में है. इट कैन जनरेट हेल लॉट ऑफ डेविएशन फॉर दैट कंपास, एंड इट कैन वेरी. सो कितना वेरी करेगी उसका कोई फिक्स्ड फिगर नहीं है बेटा. इट कैन वेरी डिपेंडिंग अपॉन कि शिप का मैग्नेटिज्म कितना है. If it is a container ship or a ship with a very powerful superstructure, ये रोल ऑन रोल ऑफ काइंड ऑफ वेसल, तो इफेक्ट भी बहुत ज्यादा होगा. ओके, अगर शिप का मैग्नेटिज्म वीक है इन इटसेल्फ तो फिर इफेक्ट कम होगा, बट यू कैन नॉट क्वांटिफाई इट. हाँ, एक काम आप कर सकते हो कि हर बार ड्रिल में जब आप कंपेयर करते हो तो आपको दोनों में एक यूजुअल डिफरेंस दिखाई देता है. सो नोट डाउन दैट डिफरेंस, and every time when you are on that heading the difference should remain more or less the same. अगर उसमें कोई फर्क आता है so that tells you that there is something wrong with one of the compasses.
ओके सर, गॉट इट, थैंक यू सर.
ओके, और बताओ बेटा, नेक्स्ट आउट. डन.
सर आप बोल रहे थे कि आफ्टर ड्राई डॉकिंग ऑल्सो मतलब हम लोग को कंपास डेविएशन कार्ड जो है रिन्यू करना चाहिए. बट लेट्स से लाइक जैसे शिप है 5-10 साल पुराना हो जाता है, तो देयर इज इवन लाइक फॉर स्पेसिफिकली फॉर लेट्स से लाइक 5 year old शिप, उसमें कोई भी नया स्टील का स्ट्रक्चर इतना रस्टिंग नहीं हुआ होता है कि उसको हम ऐड करें एंड ऑल दैट. तो still we need it, the deviation card कि सिर्फ तभी जब एक मतलब मेजर पार्ट या फिर स्टील रिन्यू हुआ है सिर्फ तभी करना चाहिए, बिकॉज आई डोंट थिंक सो इट्स अ रेगुलेशन स्टिल.
I'll tell you in detail बेटा. जो हमारी रिक्वायरमेंट है, बेसिकली टैंकर्स में वेटिंग की रिक्वायरमेंट इज़ वेरी क्लियर दैट एवरी ईयर इट शुड बी डन. Okay, for bulkies I'm not sure whether there's a mandatory requirement or not, but most of the people, they would, most of the you can say companies will have it in their policy that every year a new deviation card should be made, vessel should be swung and new deviation card should be made. इसका रीजन ये है बेटा, I'll go take you in little bit of detail. जब शिप बनता है, let us say the ship is built, it has acquired some permanent magnetism. Now induced magnetism will keep on generating depending upon the position, heading, location of the ship. जो परमानेंट मैग्नेटिज्म शिप में आ गया है, लेट अस से शिप को बनने में 1 साल लगा, उस 1 साल में जो परमानेंट मैग्नेटिज्म उसने एक्वायर किया, व्हेन द शिप कम्स आउट ऑफ द यार्ड एंड इट स्टार्ट्स मूविंग ऑन डिफरेंट हेडिंग्स, तो वो जो मैग्नेटिज्म है वो शेड ऑफ होता है. You can say about 5 to 10% of the magnetic effect is shed off in the first 6 months of delivery. डिलीवरी के बाद 6 महीने में जो 100% मैग्नेटिक फील्ड था उसका 5 या 10% शेड ऑफ हो जाता है, रिड्यूस हो जाता है. आफ्टर दैट वो जो 5-10% शेड ऑफ हुआ, आफ्टर दैट देयर इज ए वेरी स्लो reduction or change in the magnetic field, very slow, maybe 1% every year or so. So this is how the magnetism changes. एंड इसी के लिए ये रेगुलेशन बनाया गया है कि हर एक साल हम एक नया डेविएशन कार्ड बनाएंगे, चेक करेंगे. दिस नॉट ओनली टेल्स अस कि शिप के मैग्नेटिज्म में कोई चेंज आया है या नहीं, ये एक और चीज भी हमें बताता है. ड्यूरिंग द रनिंग ऑफ द शिप, इफ समबडी हैज टिंकर्ड अराउंड विद द करेक्टर्स, आपने ऊपर पेंटिंग के लिए किसी को भेजा, उसने बेटा एक स्फीयर लगा था उसको हिला के साइड में कर दिया, चिपिंग पेंटिंग कर रहा था वो, अब वो नट ढीला हो गया, स्फीयर को हिला के आगे पीछे कर दिया. Now you will never come to know until unless you make a new deviation card or you go and check the binnacle very carefully. So this is the reason why there is a annual frequency recommended. हो सकता है किसी ने वहां से कोई परमानेंट मैग्नेट करेक्टर निकाल लिया हो, फोर एंड आफ्ट मैग्नेट है, ऑथवर्ड शिप मैग्नेट है. सो देयर आर स्मॉल करेक्टर्स विच आर देयर, डेलिकेट वंस. एक फ्लिंडर बार है, हो सकता है किसी ने फ्लिंडर बार का कोई पीस मिसप्लेस कर दिया हो. सो एनी ऑफ दीज थिंग हैपन्स व्हेन यू डू दिस एनुअल चेक, immediately it will come to your notice that this has happened and you will do the correction, you will rectify it.
Okay, sir.
Okay, great. और बताओ बेटा, और doubts?
Sir, many a times we see that the deviation shouldn't be more than 3 degrees or 5 degrees. So from where have they got this value 3 degrees or 5 degrees?
बेटा, this has developed over the years. 5 डिग्री की रिकमेंडेड वैल्यू ये बोलते हैं. ये जो कंपास करेक्शन है ना, दिस इज समथिंग विच कैन नॉट बी डन 100%. कोई भी कंपास करेक्टर ये नहीं बोल सकता कि मैं ये ऐसे करेक्टर्स लगाऊंगा कि शिप की जो डेविएशन है ये निल हो जाएगी. ओके, बिकॉज बहुत सारी करेक्शंस में अप्रोक्सीमेशन, एस्टिमेशन इज इन्वॉल्व्ड. वी डू नॉट हैव प्रिसाइज इंस्ट्रूमेंट जो हमें शिप के मैग्नेटिक फील्ड का मैग्नीट्यूड बता सकें, एंड वी अप्लाई द करेक्टर्स एज पर दैट. So because of this estimation, the deviation cannot be reduced to 0. अगर ऐसा पॉसिबल होता तो डेविएशन कार्ड बनाने की जरूरत ही नहीं थी, हम उसको बिल्कुल 0 पे लाके छोड़ देते एंड इट वुड गिव एंटायरली करेक्टेड 0 डेविएशन रीडिंग्स. सो अब इन्होंने ये रिकमेंडेड वैल्यूज बनाई हैं. दिस हैज डेवलप्ड ओवर द इयर्स. दे हैव सीन कि हम कंपास को कितने लेवल तक या किस स्टेज तक करेक्ट कर सकते हैं, एंड दे हैव ऑब्जर्व्ड that you can easily with you can say moderately experienced compass adjuster, he can easily bring it to within 5 degrees. Okay, so that is how this 5 degree has come into the requirements. Many of the inspections, vetting, PSC requirements, they say that 5 degree के अंदर deviation आनी चाहिए. This is how it has developed over the years. But this 5 degree is difficult to achieve on magnetic cargo ships.
Okay, sir.
Okay. और बताओ बेटा, और doubts?
Sir, ये जो flint bar है, this is placed vertically, no, below the compass. So this is
forward,
for correct.
Forward of the compass.
Forward of the
placed
compass.
vertically.
Yes.
That's
Yes.
right. It is
So this
basically
is,
placed opposite to the funnel.
yes, to correct for any vertical components, correct?
Vertical
Of
soft
the
iron.
deviation.
Vertical soft
soft.
iron. That's
Yeah.
right.
Oh,
We will do it in
okay.
coefficient
And
Bravo.
अच्छा, okay.
Bravo में डिटेल में करेंगे इसको बेटा.
Okay, so just one quick thing. Then the soft iron spheres which are there, those are for horizontal corrections, and the vertical, what do you call, Flinders bar is for the.
They will Flinders bar is for coefficient IB induced B, and जो soft iron spheres हैं they are for coefficient delta. ये दोनों मैं जब ब्रेवो और डेल्टा में जाऊंगा मैं डिटेल में बताऊंगा आपको.
Okay, sir.
Okay. और डाउट्स बेटा? Okay, great. So let us quickly go back to the presentation. Coefficient A में ना हमारा real A is done. So मैं real A wrap up करके आपको apparent A के बारे में भी बताता हूँ. So that will finish off and we will close out coefficient A. So going back. Now let's move on to the correction of real A. How do we correct this coefficient? The correction of real A is generally not attempted, not done. The reason for it is, number one, it is very rare on a normal seagoing merchant ship that a coefficient A will exist. Because these kind of soft iron structures are not present on the ship, whatever soft iron structures are present, they are symmetrical about the compass location. Even when it is present in some ship, it is likely to be very, very small. So this is the reason why we do not attempt the correction of real A. What is done then? Since the deviation generated is constant on all the headings, it can be applied as an index error. So you will see that on a ship where real A is present, the real A value will be mentioned separately in the deviation card. Like, let us say, for example, the deviation card will tell you that the real A correction or index error correction is 1 degree east. So whatever deviation you obtain from the curve, you add 1 degree east to that deviation and it will give you the resultant deviation. So deviation being constant on all the headings, is it applied as a index error and the real A is not generally corrected. Moving ahead now. Now the second component of coefficient A, which is known as apparent A, is basically the constant deviation on all headings caused by factors other than the magnetic field. So any reason, any cause other than the magnetic field which leads to a constant error on all the headings will come under apparent A. There can be numerous reasons for generation of apparent A. Some of the examples, some possibilities which could lead to this kind of an error. You can have the magnetic needles of the card not parallel to 180 degree direction of the card. Now this is a manufacturing defect. You can visualize a card is being printed. The magnets are to be fitted exactly in the 000180 direction. But if during the construction of the card, the magnets are fitted slightly at an angle, let us say 002 and 182 direction, so there will always be a slight error which the compass will show. This has got nothing to do with magnetism, so this falls under apparent A. That's a manufacturing defect in the card. Sometimes we see there is a lubber line which is fitted on the repeater. If the lubber line is not parallel to the ship's fore and aft line, so whenever you read that lubber line to get the heading of the ship, there will be a constant error. This has got nothing to do with magnetism, and it's also a manufacturing defect, so it falls under apparent A. Other reason could be constant error in observing the bearings when the compass is initially adjusted. For example, there could be an index error in the azimuth mirror leading to wrong deviation card.
So when that wrong deviation is applied, you will get an error. So that's also a non-magnetic reason. Moving ahead now. Further reasons could be error in computing the magnetic bearing when the compass was adjusted, rapid swinging of the vessel when observing the bearing for compass adjustment. It is recommended that whenever we are doing the compass adjustment, the vessel should not be swung rapidly. It should be steadied on a particular heading before noting down the deviation. Or are angles worked out wrongly, leading to error in the calculated bearing. We usually obtain the compass error by using the azimuth, calculating the azimuth by ABC method. So if the method has been worked out wrongly, it will lead to a wrong deviation being noted down. And if we use that wrong deviation, it will give us wrong bearings or wrong heading of the ship. So there could be many other reasons also. Any reason other than magnetism which leads to a constant error on all the headings falls under the category of apparent A. Now, how do we calculate the coefficient A for the correction purpose? The value of coefficient A can be easily obtained as the mean of deviation on at least 4 equidistant headings. What does that mean? Let us take the ship on a northerly heading and note down the deviation. Let's now take the ship on a easterly heading, note down the deviation, then southerly heading and westerly heading. So all the 4 cardinal headings, we swing the ship, take it to 4 cardinal headings, and we note down the deviation on these 4 headings. Now, once you take a mean of these 4 deviations, it gives you the value of coefficient A for that particular ship. Practically, this is done using 8 deviations on cardinal and intercardinal headings. Taking this value in 8 deviations gives you more accuracy. So practically we use the deviations on cardinal and intercardinal headings and take a mean. Now you can easily test out this method or try out this method using this formula. This is the same formula which I showed you. Deviation is equal to coefficient A plus B sine cos plus C cos cos plus D sine 2 cos plus E cos 2 cos. So in this formula, if you put the cos as 0, 0, 0 and get the result, then second time you put the value as 90, third time you put the value as 180, fourth time you put the value of cos as 270. Now, once you get the answers and you take a mean, you will see that all the other coefficients B, C, D and E will get cancelled out. The only coefficient which will remain is coefficient A.
So voice chili gay.
Yeah, that's all beta. That's all. This is how coefficient A is calculated. And if it is present, then it is written down as a index error on the deviation card. So this
Understood.
completes the coefficient A. So any doubts now in this coefficient beta? Or
सर
anywhere
रियल
what
ए
we
का
have discussed?
ड्राइंग दिखाना सर रियल ए का ड्राइंग
Real A ka drawing. This is the one beta.
सर साउथ ईस्टर्ली हेडिंग एंड साउथ वेस्टर्ली हेडिंग पे जो रेड नियर टू द कंपास हेडिंग बनाया है वो मेरे को कंफ्यूज रेड और कैसे कर रहे हैं सर
ओके बेटा, वो कंफ्यूजन इसलिए हो रहा है क्योंकि इन्होंने ना ये जो 4.5 लॉन्जिट्यूडनल और बीम है बहुत छोटे बनाए हैं. आप इनको थोड़ा सा लंबा बनाओ और जो एंड शिप साइड के पास है उसे कंपास से दूर ले जाओ. यू विल गेट द करेक्ट आंसर. अगर आप किसी हेडिंग पे चाहते हो तो मैं अभी बना के दिखा देता हूँ बेटा. विच हेडिंग यू वांट टू मेक इट?
साउथ वेस्टर्ली पे बना दी सर।
साउथ वेस्टर्ली पे, ओके, अभी बना देता हूँ बेटा। और कोई डाउट इसमें बिफोर आई पुट ऑफ द प्रेजेंटेशन?
और कोई नहीं।
Sir, in one of the line it was written lubber line not parallel to ship 4 and all. Lubber line किसको कहते हैं? Lubber line किसको कहते हैं?
बेटा कई बार आप कंपास में देखते हो ना, एक थ्रेड सा लगा होता है 4.5 डायरेक्शन में। कई बार एक मार्किंग सी लगी होती है, just a small metal clip kind of thing showing the ship's head. That is called as a lubber line.
Understood. जो एकदम head on रहता है।
Right बेटा, जिससे आप अपनी heading check करते हो, so that is called as lubber line. It should be fitted in the 4.5 direction. If it is slightly offset to starboard or port, it will continuously give you wrong headings.
Understood.
Sir, I have one doubt.
बोलो बेटा।
If found, the apparent A, if found, is written on the deviation card, sorry, the coefficient A. So this is before it is, I mean, after we have sailed and we find it while in operation, right? If
बेटा बेसिकली व्हेन द शिप इज बिल्ट, तो आप जब सी ट्रायल्स के लिए जाओगे, दैट इज द टाइम व्हेन द कंपास एडजस्टर इज गोइंग टू कम एंड पुट ऑल द करेक्टर्स एंड डू द कंपास करेक्शन.
okay, sir.
So after he has done the compass correction, he will note the deviation on all the headings. So then he does this calculation. वो 8 cardinal और intercardinal heading की deviation का mean लेगा and he will check whether any value remains, and if it is there, he will mark it as coefficient A.
Sir, we can, there is an adjustment also possible. Is that not going to eradicate that? No, it will not. Okay.
No, it will not.
Okay, sir. Sir, just to clarify, sir, index error मतलब क्या होएगा sir? मतलब
Okay. इंडेक्स एरर का बेसिकली ये मतलब होता है कि जो भी रीडिंग आपको इक्विपमेंट से मिली है, उसमें ये करेक्शन सबसे पहले लगानी है. दैट विल गिव यू द करेक्टेड रीडिंग्स.
राइट सर.
सो सेक्सटेंट में भी जो सेक्सटेंट अल्टीट्यूड आपको मिला है, इंडेक्स एरर सबसे पहले लगानी है. दैट विल गिव यू द ऑब्जर्व्ड एल्टीट्यूड. सो सेम वे, अगर इंडेक्स एरर आपके डेविएशन कार्ड में लिखी गई है, कंपास रीडिंग पे सबसे पहले वो करेक्शन लगानी है. दैट विल गिव यू द कंपास रीडिंग.
Sir, but isn't that very easy to eradicate by just shifting the compass card in the right direction?
No, can't do it बेटा. कंपास कार्ड इज ए मैग्नेट, वो उसका जिधर दिल करेगा वो जाएगा.
Okay, sir. Basically, fit करने के बाद during sea trials, इसलिए they cannot readjust it. You're saying, sir?
They cannot. It is happening because of some unsymmetry in the ship structures. So वो तो हम करेक्ट नहीं कर पाएंगे, उसके लिए तो स्ट्रक्चर को सिमेट्रिकल बनाना पड़ेगा.
Right, sir. Right. Thank you, sir. Thank you, sir.
ओके, अब मैं आपको साउथ वेस्टर्ली हेडिंग पे डायग्राम बना के दिखा देता हूँ. ओके, लेट्स टेक द शिप ऑन ए साउथ वेस्टर्ली हेडिंग. शिप को ब्लैक बनाते हैं. ये हम साउथ वेस्टर्ली हेडिंग पे आ गए. अब यहाँ पे एक लॉन्जिट्यूडनल बना देते हैं. लॉन्जिट्यूडनल इज ऑन द स्टारबोर्ड साइड ऑफ द कंपास एंड फॉरवर्ड. ये लॉन्जिट्यूडनल बना दिया. And the outward ship beam is forward of the compass and towards the port side. ये मैंने beam बना दिया. Let's make the compass needle also. यहाँ पे compass needle बना देते हैं. ये compass needle का north end है. And let us make the south end also. ये compass needle का south end आ गया. The lines of force are going to enter from the south. So outward ship beam में यहाँ lines of force enter करेंगी. This will get blue polarity. 4.5 longitudinal में यहाँ पे blue end बनेगा. Let's make the red end now. The lines are going to leave out from here and here. So up to here, okay बेटा?
Now clear sir. Okay, thank you sir. Where is the south?
हो गई
north,
easterly. Okay, so easterly deviation is done. So this is how the needle is going to move. Right, beta? Clear?